This tutorial is for 3rd grade Module 4, Lesson 3. We pulled some of the lessons from Module 4 into Module 1 because they involve area. And area is found through multiplication, so we thought this would be a good chance for the students to continue to practice working on their multiplication facts and the general concept of what multiplication is. Here we have a grid with rectangles shaded on the grid. They're telling us that each square on the grid represents 1 square unit. And then they are asking the area of each of the rectangles. If I look at rectangle A, you can see how it is similar to a multiplication array. It's a configuration of rows and columns. And on figure A, we have 2 rows of 3 columns. And I can look at this as 2 times 3. So rectangle A has an area of 6 square units. Rectangle B is 2 rows with 6 units in each row. So rectangle B would be considered 12 square units. Rectangle C has 4 rows of 3 squares. 4 times 3 is 12. The area of rectangle C is 12 square units. And rectangle D is 4 rows of 5 units. 4 times 5 is 20. Therefore, the area of rectangle D is 20 square units. It's important that we include the unit as square units as a reminder that we're counting the number of squares inside the rectangle, not the distance around the rectangle, which would be the perimeter. In this section, I'm asked to draw 4 different rectangles that have an area of 8 square centimeters. I'm going to start with a fairly easy rectangle, showing just 1 row of 8 squares. I'm going to put X's in my squares just so I can count and make sure that I have 8. If I draw a box around this then, this is 1 rectangle that has an area of 8 square centimeters. I also know that I can make 8 by using 2 rows of 4. I'll mark out my 8 square centimeters, draw a box around it, and there's another rectangle with an area of 8 square centimeters. When we talked about multiplication and arrays, we described this type of array as 2 times 4 because it's 2 rows of 4. That's different than this rectangle, which would be 4 rows of 2. 4 times 2. So we consider this a different rectangle because it's representing a different multiplication problem. And I can use that same logic for my last rectangle. My first rectangle was 1 row of 8. So now I'm going to do 8 rows of 1. I'll count out the 8. There's my 8. Draw a box around it. And there are my 4 rectangles, and each one has an area of 8 square centimeters.